Hello students, in this video we'll discuss properties of the cross product and the dot product. So if we're given a vector v, which is v1 I hat plus v2 j hat plus v3 k hat, and a vector w, which is w1 I hat plus w2 j hat plus w3 k hat, we have two products we've discussed. We have the dot product, v dot product, w, and that will be v1 w1 plus v2 w2 plus v3 w3. In other words, I multiply the I components, I multiply the j components, I multiply the k components, and I add the results together to get the dot product. This is a scalar quantity, so the dot product outputs a scalar quantity. The cross product of two vectors is computed by using this formula, determinant of I, j, k, v1, v2, v3, w1, w2, w3. And this will be a vector quantity. So the dot product will output a scalar, the cross product will output a vector. So let's talk about some properties of the dot product. Property number one is the dot product is an actual product, so I can FOIL things out basically. So if I have u dot v plus w, that will be u dot v plus u dot w. So I can distribute it. Two, if I do u dot lambda times v, a scalar multiple of v, so this is a scalar multiplication of v, this is the same thing as lambda times u dot v. These two results over here allow me to FOIL dot products, which is a very useful tool. These allow me to FOIL dot products. The third property is that the dot product is commutative. So if I have u dot v, that's the same thing as v dot u. And we have the angle relationship, which is u dot v is the length of the vector u times the length of the vector v times the cosine of theta, and here theta is the angle between the vectors u and v. So theta is the angle between u and v. What this tells us is that the absolute largest the dot product can be is the product of the lengths of u and v, and that result is referred to as the Cauchy-Schwarz inequality, a very useful convex inequality that's used in a lot of mathematical inequalities. Now let's talk about properties of the cross product. Properties of the cross product. Well, the first two properties are the same for cross products. Number one, if I have u cross v plus w, that will be u cross v plus u cross w. Secondly, if you have u cross lambda times v, that's the same as lambda times u cross v. And these rules allow us to FOIL cross products. But property 3 gives us a little bit of caution because u cross v is the same as negative v cross u. So if you change the order of a cross product, it's not the same, it is the opposite or the negative of what you get when you do. So when we do this foiling, we have to be careful. So order matters here. Whereas over here, order doesn't matter. We also have an angle relationship for cross products. The angle relationship is u cross v is the same as the length of, let's put magnitude over here, the magnitude of u cross v is the magnitude of u times the magnitude of v times the sine of theta, and here again theta is the angle in between these vectors. So theta is the angle between vectors. And so what should we observe from this? As a consequence of this, we get a whole bunch of consequences. One consequence is that v cross v, if you take a vector and you cross with itself, you get the 0 vector. So a vector cross itself is the 0 vector. And one other thing that's very, very useful for cross products is if we think of the relationship with I, j, and k. So there's an easy way to remember this. If we have I, j, and k, and we put them into a circle, if you do I cross j, you get k. If you do k cross I, you get j. J cross k is equal to I. So if you go around the circle in a clockwise rotation, you can figure out the cross products. And if you go in an anti-clockwise rotation, you get the negatives of those things. So what we can see is, in some sense, the dot product and the cross product act in opposite directions of each other. When the vectors u and v are perpendicular, as they are in the case, then theta will be pi over 2, and the dot product will be 0. So the dot product is 0 when the vectors are perpendicular to each other. The cross product is 0 when the vectors are in the same direction. V and v are in the same direction. So if the vectors are in the same direction, the cross product will be 0. If the vectors are perpendicular, the dot product will be 0. And everything in between those angles gives you some parts of the dot product and some parts of the cross product. So these products are working in different directions, and we'll see this throughout the course. Thank you very much.